Fine. My name's Omalo Frederick. I teach biology, and today we'll continue from a subtopic based on the topic that we started on earlier on. This is a Form 4 topic, which is reception, response, and coordination, which is the third topic of Form 4 biology as per 844 syllabus. We had looked at the first subtopic, which was reception, response, and coordination in animals. So today we look at the second subtopic, which is reception, response, and coordination in animals. We will just have an overview of lower animals, and then we'll put in more emphasis on higher animals, which in this case we look at human beings. We do have lower animals, which include unicellular organisms, amoeba, paramecium, and then we have others which are slightly more advanced, like the arthropods. But we do have higher animals, which in this case we refer to mammals, case study of human beings. So mammals of all human beings do have a well-developed and complex means of irritability, response, and coordination. So if we pick on human beings and then look at how response and coordination is brought about, we find that we do have two main types of communication within the bodies of animals, in this case human beings. The two main types of communication are nervous communication and endocrine communication. Nervous communication is more complex and fast compared to endocrine system of communication. For nervous system of communication, we do have neurons. Neurons are specialized cells whose main function is transmission of nerve message. The nerve message which is being transmitted is also known as nerve impulse. For endocrine system is also known as hormonal system of communication. In this case, we have hormones playing a major role in communication or transmission of communication from one part of the body of a living organism to another part of the body of the living organism. Hormonal communication or endocrine communication is usually slow compared to nervous communication. So in short, within the bodies of animals, in this case human beings, we do have two main systems of communication. These two systems of communication are nervous system, and then second would be endocrine system. In both systems of communication, we do have receptors, effectors, and coordination system. Earlier on in the other topics, we talked about receptors being specialized organs or cells that are capable of detecting stimuli. After detecting stimuli is taken to particular neurons, which then take it to the coordination system. We do have effectors. Effectors are specialized cells or organs that bring about the desired change. So, receptors, effectors. Then you have coordination system. As mentioned, receptors are specialized organs whose main function is to detect or perceive stimuli. Like the eyes will perceive light. Light in this case being the stimulus. We have the ears that perceive sound. Sound in this case is the stimulus. We have the tongue that detects chemical substances. We have the nose that also detects chemical substances. We have the skin that detects light and many others. So we do have different types of receptors, as we've mentioned. We have eyes, ears, nose, skin. Then you have effectors. Effectors are tissues or organs that bring about the change that is needed. Change due to a particular stimulus. For example, we can talk about a hot object. When I take this pen here to represent a hot object, then when I touch the hot object, the skin, which is the receptor, will receive the stimulus. Stimulus being hotness. Then the skin will take that particular stimulus, take it to a neuron. The neuron will take it to integration system, which in this case could be the brain or spinal cord. The nerve impulse will then be integrated. The integrated message will then be taken to effectors. Effectors in this case, we have biceps and triceps. The biceps will contract while triceps will relax. Then the arm will be withdrawn from the hot object. So in that case, we have receptors receiving the stimulus, effectors bringing about the desired change due to a particular stimulus. Even our eyelids can be effectors, because when the eyes are exposed to bright light, then what happens is the eyelids shut. So in that case, they've served as effectors. Then coordination system, we talk about different neurons, different organs that work in coordination or work together in harmony to ensure that stimulus taken to the integration system, the integrated information then taken to the effectors. So coordination system is made up of neurons and can also involve other different body organs. Then we'll start off with the nervous system. Then later on we'll look into endocrine system or hormonal system. So nervous system, which is said is the quickest means of communication because it happens within a split of a second. For example, when a fly passes close to our eyes, what happens? We shut our eyes almost instantly, meaning that the passing fly or object has served a stimulus, nerve impulse has been generated, taken to the brain for integration, then the brain has taken the integrated message to the neurons, then the neurons have brought that particular information to the eyelids, which respond by shutting. So it happens within a split of a second. So nervous system of communication is the quickest means by which information is transmitted from one part of the body to another part of the body and the desired change brought about. Then the nervous system is divided into two main parts or two main major parts. We have first branch is central nervous system. Also known as CNS. The other branch of nervous system is peripheral nervous system. Sometimes referred to, it's also known as PNS. Fine. So, central nervous system or CNS is made up of brain and spinal cord, while peripheral nervous system is made up of cranial nerves, that is the nerves that emerge from the brain and are spread to other parts of the body organs. And then you have spinal nerves, nerves that emerge from spinal cord. So, central nervous system made up of two main parts. the brain and spinal cord. Spinal cord is also part of the brain because the spinal cord emerges from the posterior part of the brain. So if I take this diagram here to represent the brain, the anterior front part, and then the back part, you see I have a small extension which is in form of a thread, usually broad from the upper part and narrows towards the lower end. So brain and spinal cord form central nervous system. Central nervous system is the section of nervous system that interprets or integrates a nerve message. For example, when you take a drink of maybe a liquid substance, you don't know whether it's bitter, you cannot tell whether it's sweet. But that sweetness or the taste of that particular substance will be detected by the tongue. Then the tongue will take that, the neurons within the tongue will take that particular nerve impulse to the brain or spinal cord for integration. Integration in this case means that particular taste will be given a meaning, sweet or bitter. So it is this brain or spinal cord that will interpret or integrate a particular nerve impulse. If you touch an object, maybe walk into a room and then you happen to touch a surface. Maybe it's a hot surface. You'll have to touch it, and then after some few seconds, that's when you realize that it's hot, and then you end up withdrawing your arm. That means a nerve impulse was generated, taken to the spinal cord for integration or interpretation. After that, the necessary action taken by the muscles. So they integrate or interpret nerve impulse. Then you have peripheral nervous system. Peripheral nervous system serve as a link between the cranium, or the brain and other body organs or body parts. We also have spinal nerves that link the spinal cord to several body organs and body parts. So peripheral nervous system serve as a link between the brain and other body parts, spinal cord and other body parts. So in summary, we can draw a flow chart representing nervous system. So in this chart we have nervous system, divided in central nervous system, bracket CNS, and peripheral. PNS. Then central nervous system made up of two main parts, the brain and then spinal cord. On this other end we have peripheral nervous system divided into cranial nerves, and spinal nerves. Like that. So divisions of nervous system: central nervous system made up of the brain and spinal cord, peripheral nervous system which is divided into cranial nerves, the nerves that originate from the brain and then link the brain to other body organs or body parts, spinal nerves that emerge from the spinal cord and connect the spinal cord to other body parts or body organs. Those are the main components of the central nervous system. Then we look into each and every type of component of central nervous system and peripheral nervous system later. So we look at the brain on its own, spinal cord on its own, cranial nerves by themselves, and spinal nerves by themselves. For now, we look at structure and function of a nerve cell. We know that the nervous system is made up of billions of nerve cells, also known as neurons. And we know that a nerve cell is a modified cell whose function is transmission of nerve impulse, also known as nerve message. Since nerve cells or neurons are the structures that play important role in a nervous system, we have to look at the structure and various components of the nerve cell and then look at its function. So, structure and function. The neuron. Fine. In terms of function, the function of a nerve cell or neuron is just one: transmission of nerve impulse from one part of the body to another part of the body. So that's the function of neuron. So neuron, as you said, is a modified cell whose main function is transmission of nerve impulse from one part of the body to another part of the body. It is modified in the sense that it has certain components that other cells don't have that enable it to transmit nerve impulse. So now that we know the function, let's look at the structure of a neuron. So in terms of structure, I'll draw a generalized diagram of a neuron, and then later on we'll come to types of neurons. Fine. So in terms of structure, a neuron has a circular structure. This circular structure has nucleus within its middle. So this circular structure has nucleus. The circular structure is known as centron or cell body. Inside the centron or cell body, there is a cytoplasm. But this cytoplasm now is known as exoplasm. Exoplasm is a fluid which is in form of a gel in which the nucleus is suspended. The centron has some protrusions, some parts that protrude externally. The protrusions normally emerge from the cell membrane of the centron. So have sections that protrude. These sections that protrude from the centron or cell body are known as axons. Axons. If it's one, axon. At the terminal ends of the axons, there are fine finger-like projections that emerge from the axon. So you have fine finger-like projections. These fine finger-like projections have swollen terminal ends. These fine finger-like projections that have swollen terminal ends, these are known as dendrites. If it's one, dendrite. Since there are several, dendrites. So we have axoplasm, axons, not axons but dendrons, not axons, dendrons. So we have cell body forming protrusions. Protrusions are known as dendrons. At the terminal end of dendrons, there are fine finger-like projections known as dendrites, and dendrites have swollen terminal ends. These swollen terminal ends are known as knobs, but I'll ignore it, we'll come to them later. So, axoplasm is also found inside the dendrons. Then, in some neurons, one of the dendrons elongates or becomes long to form a structure known as axon. So let me pick this one. So, the dendron here elongates or becomes long. That elongated dendron is what is known as axon. So these two dendrons have not elongated. The dendron here, dendron here. The dendron that we had here is the one that have extended to form an elongated dendron. Elongated dendron is called axon. Inside the axon, there is also axoplasm. So axoplasm is found in the cell body. Axoplasm is found in the dendrons. Axoplasm is also found within the axon. Axon is the part where nerve message travels. The nerve message or nerve impulse will move along the axon. How nerve impulse moves, a subtopic on its own later on. Then, the axon is covered with a layer of fats. Let's take that line to represent the layer of fats that covers the axon. The layer of fats that covers the axon is known as myelin sheath. So myelin sheath is the layer of fats that covers the axon. The function or role of the myelin sheath is to serve as shock absorber, such that if the nerve or neuron is hit mechanically, axon is not destroyed because the myelin sheath will serve as shock absorber. Then myelin sheath, which is the layer of fats, is covered by a thin membrane. The thin membrane that covers the myelin sheath is known as neurylema. So neurylema is a thin membrane that covers the myelin sheath. Myelin sheath is never continuous as I have drawn it, but myelin sheath has some 1 millimeter constrictions. So after 1 millimeter, there's a part that curves in, a constriction. So we'll have constrictions of 1 millimeter intervals. So this is what we have. Constriction, constriction there. constriction, another constriction. The constrictions that are found at 1 millimeter intervals are known as nodes of Ranvier. If node of Ranvier. Node of Ranvier. So, myelin sheath along with the neurulema is never continuous throughout, but instead they have constrictions of 1 millimeter apart. Those constrictions are known as nodes of Ranvier, if it's one node of Ranvier. The function or role played by node of Ranvier is to speed up nerve impulse along the axon. So they propagate nerve impulses as they move along the axon. Then, on neurulema, there is a special type of cell known as Schwann cell. So, Schwann cells are special cells that are found on the membrane known as neurulema. The function of Schwann cells are two. They have two main functions. One, secretion of myelin sheath, and also secretion or formation of neurulema. As I've mentioned before, neurulema is the membrane that covers myelin sheath. It is secreted by Schwann cells. Myelin sheath, which is the layer of fats that cover the axon, is also secreted by the Schwann cells. Then, at the terminal end of axon, we also have dendrites. We will later on look at the differences between dendrites that are found on one terminal end of the neuron, like in this case, dendrites that are found on the side of the cell body and dendrites that are found away from the cell body. This generalized diagram that I've drawn represents motor neuron. Motor neuron is a special type of neuron that transmits nerve impulses from central nervous system to the effectors. So I've used motor neuron here to represent a generalized diagram of a neuron, because we're only interested in knowing various parts of the neuron, as I said earlier on from the structure. So to give a summary, we have a centron, which is the cell body, which has a nucleus within it. The nucleus is suspended within exoplasm, which can be compared to cytoplasm of a cell. There are protrusions which are found within the centron. These protrusions are known as dendrons, if it's one dendron. At the terminal end of each and every dendron, there are fine finger-like projections, which are known as dendrites. Then, one of the dendrons elongates, becomes long. When it elongates, it forms a structure known as axon. The axon is covered with a layer of fats known as myelin sheath. Myelin sheath, we said, serves as shock absorber. Then the myelin sheath is covered by a thin membrane. That thin membrane is known as neurulema. Then, on the surface of the cell membrane, surface of neurulema, we have specialized cells known as Schwann cells. We mentioned that Schwann cells have two main functions. One, secretion of myelin sheath. Two, secretion or formation of neurulema. Both neurulema and myelin sheath have constrictions which are 1 millimeter apart. The constrictions are known as nodes of Ranvier. If it's one, node of Ranvier. We mentioned that the function of node of Ranvier, nodes of Ranvier, is to propagate or make nerve impulses to move faster along the neuron. Because if a nerve impulse reaches it, jumps over, moves with, jumps over. So when it jumps over, skips over, then it means the nerve impulse will be moving faster as compared to when it moves smoothly. We have dendrites that receive nerve impulse, and then we have dendrites that release nerve impulse or pass over nerve impulse to another neuron or to effector. For example, this one being a motor neuron, the dendrites which are found on the side of the cell body are known as receptor dendrites. They will receive nerve impulse from central nervous system. Then they'll transmit nerve impulse along the axon. Then at the terminal end we have receptors. So these are called receptor dendrites. They will release nerve impulse that has been integrated from the central nervous system, pass it over to the effectors. Then the effectors also have dendrites that will receive, or they'll also have specialized tissues that will receive the nerve impulse and then particular action is taken. So that brings us to the end of the structure and function of the various parts of the neuron or nerve cell. Next subtopic could be types of neurons. Types of neurons. We have three different types of neurons, namely sensory neurons, two motor neurons, and then three intermediate, also known as relay neurons. So these are the three types of neurons that exist within our bodies. Sensory neurons are connected to sensory organs, so they receive or perceive nerve impulses. They'll be found on the skin, within the eyes. Once they perceive or receive the nerve impulse, they'll take it to the central nervous system for integration. Motor neurons transmit integrated or interpreted nerve impulse from central nervous system to effectors. Intermediate neurons are found inside central nervous system, and they link central nervous system to sensory neurons. They also link central nervous system to motor neurons. So there is a link between sensory neurons and CNS. There also a link between CNS and motor neurons. So they are intermediate or relay neurons because they link the two types of neurons through central nervous system. So later on we look at the structure of the three types of neurons and why they are classified into three different categories of neurons.